Hello, welcome to the third session of applied thermodynamics. Okay, in the last two sessions we have discussed about the velocity diagram of impulse turbine and few terms like efficiency, power, force calculation and all. In second session we have discussed about the numericals based on impulse turbine. Correct? Now in day 3 we will once again revise the concept of impulse turbine through some videos. Then I'll explain you the working of reaction turbine. Then we will see the difference between impulse turbine and reaction turbine. Then there is very important concept called as degree of reaction in case of reaction turbine. And then finally I'll explain you the velocity diagram of reaction turbine. Correct? So now let's understand the concept of impulse turbine one more time. We can see this is the rotor, and on this rotor the blades are mounted. Correct? The steam which is coming out of the nozzle will be bombarded on these rotors, okay, in the tangential direction. Correct? Now what is happening in the system? Okay, so this particular section is indicating the fixed blade and this green section is indicating the moving blades. Correct? Now whenever the steam is coming out of the nozzle, okay, what will happen? It will be bombarded on the fixed blades. Now what is the function of fixed blade? The function of fixed blade is what? To guide the flow of the steam over the moving blades, right? Now as we know, the function of nozzle is what? The nozzle helps to increase the kinetic energy of the steam. That means what? There is increment in the velocity, right? So we can see by pressure velocity diagram over here, whenever the steam is coming out of the nozzle, there is increment in the velocity of the steam, right? So this slope is positive over here. This is the line which is indicating the increment in the velocity. Now when this steam will be guided over moving blades, what will happen? The moving blades will absorb that particular energy, and some part of kinetic energy will be absorbed for the rotation of the rotation of these moving blades. That's why, okay, whatever the energy which is absorbed, because of that there is decrement in the steam velocity. So we can see we have the negative slope which is shown by this particular line, which indicates the decrement in the steam velocity. Now why the velocity has got decreased? Because the moving blades are utilizing that energy for their rotation purpose. That's why there is drop in the velocity, right? Now let's see what is happening for the pressure. Now when the steam is coming out of the nozzle, okay, as there is increment in the velocity, there will be decrement in the pressure. So we can see, okay, we have the decrement in the pressure, okay, and there is no pressure change when the steam is passing over the moving blades. So that is what I have mentioned over here. Okay, pressure will remain constant while the flow of steam over moving blades. Now let's understand the working of impulse turbine, especially about the example which is a D-level turbine. This is the prototype of impulse turbine. So we can see these are the fixed nozzles over here, okay, and these nozzle will increase the kinetic energy of the steam, and that will be bombarded on the rotor so that this particular system will rotate and the electricity will get generated, right? So let's see the working of this D-level prototype turbine. So we can see the tachometer which is used over here for the RPM measurement of the steam turbine. Okay, let's see this video one more time for better understanding. Okay, so this is all about the impulse turbine. So I hope you have understood the concept. Thank you so much.